Welcome to Chapter 12, Supervised Data Mining. In this chapter, we will explore various supervised data mining techniques and their applications. Let's get started. By the end of this chapter, you will be able to explain key differences among supervised data mining techniques, apply the k-nearest neighbors method to classify new records, apply the naive Bayes method to classify new records. The goal of supervised data mining is to classify or predict the outcome of a new observation, case, or record. We can classify a categorical target or response outcome and predict a numerical target or response outcome. Scoring a record involves classifying or predicting the value of the target variable of a new observation given the values of the predictor variables. We use cross-validation to avoid overfitting and evaluate performance metrics such as true positives, true negatives, false negatives, cumulative lift charts, decile-wise lift charts, and ROC curves for classification, as well as RMSE and MAD for prediction. Let's look at some supervised data mining techniques, their advantages and limitations. Linear regression, widely used, computationally efficient, and yields the best mathematical function with interpretable estimates and predictor importance information. However, it is mostly used for prediction and can be affected by nonlinearity, collinearity between predictor variables, and other violations of assumptions. Logistic regression, computationally efficient and provides information on the importance of predictor variables and probabilistic interpretation. It is only for classification and can be affected by collinearity between predictor variables. K-nearest neighbors, used for both classification and prediction, particularly effective as a classifier, easy to understand and does not assume any underlying distribution for the target variable. However, it provides no information on predictor importance, searches the entire training data set, and is computationally expensive. Naive Bayes, simple, efficient, and effective, but only for classification, assumes independence among predictor variables, and predictor variables must be categorical or transformed into categories through binning. Classification and regression trees, CART, used for both classification and prediction, easily explained and justified to non-technical decision makers, provides information on the importance of predictor variables, does not assume any underlying distribution for the target variable, and is robust when dealing with outliers and missing values. However, it cannot capture interactions among variables, is sensitive to changes in data, and single trees are prone to overfitting. Ensemble tree models used for both classification and prediction addresses the overfitting issue of single tree models but does not provide the tree diagram, thus lacks interpretability. Thank you for your attention. This concludes our discussion on supervised data mining techniques.